Okay, hi everybody, my name's Fallon. I'm working with Architype for about 3 years, and I'm taking a little bit of a different slant to the kind of technical presentation you've had this morning from Thomas. I won't go into too much detail about Architype, except that we're a 35-year-old practice this year, and we spent the last, I'd say, 15-20 years challenging the business as usual approach in the construction industry and challenging what our perceptions of sustainability are across the construction industry as well. That's led us as a practice to focusing on building performance, really as a quality assured way of assuring buildings are performing in a sustainable manner. What does that mean though for performance generally? It means that we can focus on occupant health, reduction in carbon impact of buildings, and most importantly in relation to fuel poverty, which is the focus of part of this presentation, that we can have an increased level of income for occupants to spend in the local economy or to have themselves, which is the pivot point really of fuel poverty, is about that income level versus the fuel costs that people face on a weekly or monthly basis, particularly in the wintertime. Our work ranges across a variety of sectors and budgets, and we have just a small selection of projects at the moment that we have currently delivered, that are certified or are currently on site or in planning. So top row of schools are all certified Passivhaus schools. We have some housing projects, and we have some archival storage buildings currently on site. The Imperial Moore Museum project here, I think, has had one of the lowest air pressure test results in the country of 0.03 air changes. It's very easy because there's no windows and doors apart from the main entry point, so I'm disappointed it's not lower. We also have enterprise and business hub centres, Bicester, University of East Anglia, and then our latest batch of schools. So there's the Passivhaus McKinlett School, True School, first Passivhaus in Wales on the left that I'm involved with closely, and a variety of other projects across the London docks and Sutton in London that are going through stage 3 and 4 at the moment, that are also looking to be certified secondary schools. Again, not to repeat some of what Thomas has already said, but why are we looking at Passivhaus specifically? Well, we specialise in Passivhaus because of our building performance focus as a practice, and because that this weakness exists in the energy sector, in the construction sector at the moment, where we design and there's a complete disconnection still between the design and the end use values that we get when a property or a building is occupied. Passivhaus isn't the be-all and end-all though for everything. We still have to reassess and establish sensible user profiles for plug-in appliances and heat loads. So user behaviour has a huge impact on how we report on end use and post-occupancy use buildings in the UK. And this is just an interesting quote from Wolfgang Feist, who came to visit some of our first Passivhaus schools about a decade ago now, where, Passivhaus is an energy standard. It's not an agendaed standard attached to a product or a supplier. It's very building physics focused, and the intent of his research and the objectives from his research in the early 90s was about this law of physics and how buildings weren't performing, even though the insulation and building codes had all increased since the 70s, since that 1970s oil crisis. We've already improved performance several times over in the schools, where we've done several studies with UCL and other universities looking at thermal comfort factors in schools and running costs, including post-occupancy running costs. So this is just a quick graph example for those of you that probably can't see this very well, unfortunately, down the back of the room. We're looking at a Monday to Friday profile in 2014 in December of a 1970s very poorly insulated school. We can see the diurnal temperature flow across from a Monday to a Tuesday, for example, can range to up to about 6 degrees Celsius. And there's also other evidence there in terms of children's concentration and children's health in schools being affected by these big swings when you also couple them with the CO2 information, which, because of time today, I haven't put up here for you as an example. If we compare this to one of our naturally vented pre-Passivhaus schools in 2009, we can see that even without heat recovery and without really utilising the full suite of Passivhaus approach on the school, we're immediately starting to reduce that profile over the day in the same month. Our first generation Passivhaus school, because again there was lots of lessons learned through the schools process with Architype, over about 20 schools now, including the ones that are just on site, where we were able to employ more lessons learned. And obviously the air tightness, which Thomas has already mentioned, is the biggest kind of quality assurance factor that we can go for, has really had a major impact on thermal comfort in that school. And when we add Wilkinson onto that in 2013, and shortly this will be updated with subsequent studies in schools, we can see that that value's got more and more tied together closer to that 21 degree temperature for comfort that we're looking at. Again, this is just a quick energy use comparison with the blue indicating the CIBC benchmarking energy standards on the left, and then the progression of our naturally ventilated low energy schools across to our Passivhaus airtight mechanically ventilated schools on the right. So we can see if we're looking at an overall energy use, this is the actual monitored use of these schools as well. So that's why the figures aren't above certain percentages. It's actually the end use monitoring that we've been doing, and we're starting to do that now with our housing, and hopefully at the end of this year we'll have a number of profiles and typologies to assess from that perspective. A little bit on fuel poverty. Did a little bit more research on this over the last couple of months, and being involved with the Agar Grove project, you can't not but be involved in some of this information. Some of the figures stand for themselves here. So fuel poverty is thrown around a lot, and it's quite a political term, but there's quite a lot of hard evidence and facts backing up what fuel poverty is and how we deal with it as a construction industry. So we actually had Sadiq Khan come to Agar Grove last week, and we had the housing minister out a couple of weeks before that as well. So the actual idea of using Passivhaus to mitigate and buffer fuel poverty is now becoming more of a political agenda, which hopefully isn't a disastrous thing for Passivhaus and is a positive thing. But there is a growing awareness of the benefits of this across trying to mitigate this issue in the UK. So again, a couple of other statistics for those who just might be unable to read the text at the back. Some really interesting findings. This fuel poverty statistics report really reports on the actual typologies of buildings and the heat loss values assigned with different eras of buildings and different areas and square meterages and different types of units, which is really fascinating read. It's one of the only reports out there that actually relates fuel poverty to building fabric. And there was just some interesting statistics, such as only 7.7% of fuel poor households live in a fuel poverty energy efficiency rated building of band C or above. So the fuel poverty SAP rating basically is a SAP calculation, but it takes into account more complicated values to do with changing policies and how that might affect fuel poor households. Without getting into the really complicated maths at the end of that, that is a simple explanation. And the other important thing that I think is useful to know, especially when speaking about Agar, is that multi-unit flats have the most energy efficient. So following on from what Thomas said about the skyscraper in New York, we're only looking at about 7% of occupants nationally in fuel poverty and multi-unit development. So again, in terms of design, density, looking at going forward and in terms of solving our housing crisis, the less semi-detached, low-density, sprawling suburbs we create, the less potential risk we put on our end users at the end of the day. And the last comment, which is just a constant challenge when presenting any information about fuel poverty or monitoring results from Passivhaus buildings, is that we cannot control the occupant. The occupant actually exacerbates fuel poverty more in ways they don't really appreciate. And what we can do as designers and architects and suppliers in the construction industry is buffer that occupant from themselves. And I'll go into that in a little bit more detail. Agar Grove is the main client for Agar Grove is Camden, and they have a great commitment to eradicating fuel poverty and creating low energy buildings in terms of their various mandates and policies. They have a very interesting pilot solar project where they're looking at PV, battery storage across a couple of councils in North London. They've had a well and warm grants and information service for occupants, and only about 13.1% of households in Camden at the moment are estimated to be in fuel poverty. A little bit of debate about fuel poverty and the energy sector in general. I mean, what the construction and energy sector responses have been kind of typically slightly off-grid, in my humble opinion, excuse the pun, where we're looking at energy creation and energy offsetting and carbon offsetting rather than actually reducing demand with a fabric-forced approach. We aren't accountable in relation to the energy sector and construction delivery, so several people involved in very complicated projects that mightn't even be Passivhaus related, especially in a D&B contractual situation. There's really very little accountability between reports and coordinating reports and how other consultants are reporting energy results, which is quite difficult at scale to deal with when you deal with the mass and the kind of quantity of people that are involved in the supply chain and the design chain. The performance gap is well evidenced. Generally, there's a lack of focus on the occupant and well-being because it's all about developer margins and kind of getting out of the defects liability period, moving on as quickly as you can, and trying to leave all the problems to the maintenance or facilities teams in these local authorities or housing associations. So all this is kind of health, environmental, and economic impacts that we should be able to buffer using a Passivhaus approach. So how do we protect the most vulnerable in society from this kind of external influence as well as their own internal behaviour? Well, for example, at the moment, Igloo, this app has come out recently in the car industry where you can utilise when the grid is cleaner at certain times of the day to actually charge your car, which could reduce the carbon that you use for electric car charger by up to 20%. There's an interesting EU clause that says that energy should be supplied for all. If that's restricted or limited by Ofgem or post-Brexit, how does that affect that basic kind of almost human right of being able to supply energy to people even if they're in the black in terms of debt or credit rating history? We have a bit of irony between the fuel poor network scheme and the decarbonisation of the electricity network. So we have, on the one hand, people being offered subsidies to change from electricity to gas in fuel poor households. At the same time then, we're also decarbonising the electricity grid. All these other companies are feeding in renewable energy. We have a lot of activisation in that regard. So there's this contradiction. Are we going down the gas or electricity route? Which infrastructure is more set up for providing energy in the future? And when we have a set of buildings in 20 or 30 years' time, like John Bootland mentioned, this mandate to government about Passivhaus for all buildings by 2030. How are we going to deal with the energy direction at that particular point? And another key point is for fuel poverty, the fuel efficiency tariffs that are going to knock in 2021 are going to be much more based on load and bolt-on in relation to, we're going to have a base level of energy sold to us, and then you might choose to bolt on or get rewarded for energy used during the day at different points in the day. Which means if you're an unemployed, fuel-poor household and you're at home at peak time during the day, you may well be penalised for that peak energy use unless that baseline energy for all is built back into the system. So there's quite a lot of complexity to the industry that we're involved in that Passivhaus offers a very significant yet modest solution to, with no real energy-driven agenda like all the confusing agendas we've just looked at there. Which brings me on to what I've mentioned today a few times about fuel poverty buffering. So this scheme, we've been involved with Hill Partnerships Limited, one of the biggest house builders in the UK. The original design was by Hawkins Brown and May Architects in conjunction with Peter Brett Associates and Max Fordham, and that was for the Borough of London Camden client, who have previously championed Passivhaus schemes such as Chester Balmore, which again we were also the delivery architect for under the contractor. This project is certified from about April last year. It was at that point the tallest Passivhaus high-rise, high-density development in the UK. I still believe it is. There's a couple of towers and things out there, but they're not actually formally certified yet. And this is just an image of the existing site. So there's a lot of 1970s uninsulated, single double glazed blocks on the site, very low density. Block A is just outlined in pink, where we've started the redevelopment of this whole scheme, which is 493 homes, 345 of which are going to be to the Passivhaus standard, and Architype have been involved in the delivery until May 2020 of 96 of those homes, with the first 38 delivered already and finished last year. So if we just look at the kind of site, again, courtesy of May and Hawkins Brown, the image, we're looking at a completed Block A already last year, and Architype are involved in the delivery at the moment on site of Block G, F and H, with the later phases coming over the next 5 to 6 years to be completed. So very ambitious scheme, containing a complete, almost Enerfit refurbishment of Lulworth Tower in the centre of the scheme there. Very exciting and also quite stressful project to be involved in. So just coming back to a little bit about energy balance, because I'm going to come on to that in a few slides. What are we looking at when we talk about energy loss? Well, again, Thomas has touched on this already in terms of the losses through the building envelope. Infiltration and ventilation being kind of critical areas that really make a difference to the performance. And then we also have, however my text has slipped, apologies, we also have the gains in the building fabric, which are becoming increasingly important in housing design in relation to sensible glazing ratios and how we deliver that over the next 50 to 80 years time, when climates are predicted to get warmer and more humid. So people, heating system, appliances and plug-in power are big gains that we need to effectively balance evenly in our buildings. So if we have more losses, we have a heating demand. If we have more gains, we have a cooling demand. What Passivhaus tries to do is actually create as equal a balance as possible. So this is the energy balance graph from Agar, Block A, where we have in orange up the very top the kind of leftover residual heating demand, and on that makes up the gains. And on the left we have the losses. So at the moment you can see the wall and the windows are where we have the most losses over the building. followed by thermal bridges, ventilation, and then infiltration with the floor and the roof. Why is that? Why is the energy balance? Oh, it's actually rotated. I don't know what is wrong with that. Our AV guy is talking. There's just a rotation on the screen. A rotation of an image. Okay. Well, if everyone turns their head to the right by 90 degrees, you can see an air tightness kind of axonometric of Agar Grove, which was describing the form factor, really. So it was you'll see some better images, hopefully, if they're not rotated in a couple of minutes. We're able to have a there's quite a large amount of glazing on this scheme, and very, very little heat loss through the floor and roof because of the really, really good form factor. So it has a form factor of 1.6. Apologies for the kind of crazy rotation of that image. And the next area I just wanted to describe at the bottom here is the 12-month heating balance here of the building. So what's in grey is the energy demand predicted across the building, the project over the 12 months. And what we're looking at is 7 or 8 months in the middle where there will be no heat demand. And actually we've had Camden have completed some post-occupancy surveys throughout the winter of the first 38 households that have gone into Block A. And again, similarly to what Thomas has mentioned, there has been no turning on of heating or requirement for heating, and I'll show you some of those temperatures as evidence shortly. This is the north elevation to Block A. Again, there's a lot more glazing on this than we would typically do on a small-scale housing development, but the good form factor, 1.6, allows us to sustain this. On the next phase of the next 57 units, the form factors are less optimised, so we've had to go back and had a look at revising some of the adopted design to better comply with Passivhaus. So again, I think the earlier you can engage in Passivhaus principles on big urban schemes like this, the better. So just on the left, thanks to Warm, who's one of the UK certifiers, set up really useful templates for us to gain some information. On the left-hand side, you have the losses through the glazing in the north elevation versus the gains. Okay, so there's still some radiation gains on the north facade that we can take into account, which is very positive. The south elevation of Agar Grove is dramatically different, and the design intent was a more community-based intent by Hawkins Brown originally, which was to connect people across a series of walkways and balconies and terraces facing south. And luckily, this provided a great opportunity to avail of a lot of solar gains, but we needed obviously a healthy amount of shading, which the walkways also provided us. So we have almost an equal power on losses and gains there, because again, the glazing was slightly overglazed, and that this balance between the gains and the losses has quite a close relationship on the south facade. This is just a little example of the intent of that space, and the brise-soleil screens that were an original architectural intent by the design architects actually also being able to provide some shading within the overall shading calculation for Block A. 2 minutes, okay. All right, so again, that great report, and hopefully no more rotated images. The Fuel Poverty Statistics Report recommends this typical 18 to 21 degrees set point temperature for thermal comfort for the majority of households. As we all know, we're the geeks in the audience, as Thomas said. You're going to appreciate that PHPP, the Passivhaus software, utilises design temperature of 20 degrees, which of course you can adjust in the PHPP software to assess where your building is. We also have the adaptive range of temperatures then that we can look at, because we have elderly people typically more comfortable at 23 degrees, and depends on the level of activity, etc., etc. This simple axonometric just shows where we've a certain amount of flats where we've had monitoring through the first winter period. That was the north elevation. This is the south elevation here with the balcony walkways made transparent. So we can see the flat 8 has a little bit more exposure externally compared to flat 6, which is a little bit more tucked in. So again, as Thomas mentioned in the high-rise building in New York, the mid conditioning unit is going to be a very, very efficient unit, and allowed us to optimize the U values in this building as well, down to a much more reduced wall insulation cavity than was predicted at tender. This is the first kind of 3-month profiling attempt we've done on flat 6, and if we just look quickly, we're at an average humidity of 40%, which to me is maybe a little bit low. So we're going to look at how it's still within a very healthy range, but I'm just curious as to how the ventilation system's engaging with that. So we're going to explore that over the next couple of weeks. And we have an average temperature internally at the moment of 22.6 degrees. So this is from the 6th of December until last week. So through a couple of cold snaps, we've had a very steady constant temperature in those buildings. The same for flat 8, so the slightly more exposed flat. We've had the same similar humidity reading, and we have a slightly increased temperature, which again, because we've slightly more solar gain from that east facade with some glazing located there that flat 6 doesn't have. And again, we're in the middle of interrogating this because this was all taken of an average external humidity of 83% and an average temperature through this whole period of 7 degrees. Now, you might be asking me why there's a gap in the data. Just want to kind of illustrate that we have these online systems, and you set up for soft landings or post-occupancy contracts when you're delivering at scale, and sometimes there's a limitation to how these systems are set up, so we can only download data up to the last 4 weeks. So if you miss a couple of days, that's your tough luck, which is a real pity because it's quite frustrating to try and gather data in a consistent manner across several fronts and several schemes when you're having to micromanage the online system. So maybe a word of kind of warning or advice about specifying this in client briefs and in performance directives, that we need to be able to access online information as much as possible and not just go for the cheapest option. Okay. Final thoughts at the very end. The most interesting bit at the end in terms of design value. So there's a couple of data privacy issues that we're dealing with Camden at the moment, but hopefully the next time I'm presenting to a group we'll be able to have the live data. But this is just referring back to the fuel poverty statistics report, where we have the average 3-bed, 2-bed flat in the national survey done with an average cost of £560 per year to the occupant. The typical same flat in Block A should cost an average of £162.50, so about £13 a month instead of about £50 a month, and that is an overall increase of 71%. It would be more, it would be up to 90% if this was a set of semi-detached houses. Because it's a very, very efficient block already in terms of its form factor, the improvement is about 70 to 75%. And just finally, just flying through the last bits, what is our kind of duty, I think, as a set of construction industry experts? We need to have a fabric first approach, which isn't being done in the industry at the moment, and it isn't being pushed in terms of policy. We have some feedback just from the Passivhaus Trust on the level and quantity of housing associations and local authorities that are already adopting Passivhaus. So there's a massive list there, over 600 or 700 housing dwellings already completed, and more and more take up across the UK, including Scotland and Wales as we speak. And I think the current challenges facing fuel poverty in the UK will move on to user behaviour, avoid selling the rebound effect. So instead of telling people like you have a weight loss app where you say you earn 300 more calories today, that doesn't mean you have 4 more biscuits. It means you save those calories and don't actually use them. Where we have energy companies online on the radio at the moment saying you can use more energy, you can boil thousands more cups of tea because we're making your fuel cheaper. Well, that's not going to really eradicate fuel poverty because the client is going to have to absorb that cost in another way. And if we have incentivised energy tariffs that reward the low energy occupant but also protect the fuel poverty households, I think that's the major challenge for fuel poverty going forward in the future.